From the assertion, we have to decide whether that particular statement is true or not. Here the assertion is given as follows. The stability of the system is assured if the region of convergence includes the unit circle in the z-plane. Means what? Here, for stable systems, the ROC includes the unit circle. Then only the system is going to have both Z transform as well as the Fourier transform. Means that the transform is going to converge into Fourier transform on the unit circle of a Z transform. Hence, the statement given for the assertion is true. Comes to the reason. For the causal stable system, all the poles should be outside the unit circle in the Z-plane. Here we have to know what do you mean by causal stable system. Causality defined by the ROC, which is outside of the rightmost pole. For the stable system, the ROC should include the unit circle. That means all the poles should lie inside the unit circle. But in the reason, they mention the poles are located outside the unit circle. That means the reason is false. Here the assertion is true and the reason is false. Hence the option is C. Here we have to find out the output noise power available at the channel output. Here h of t is the impulse response of the channel and the Rn of tau is the input autocorrelation function. N0 is the two-sided PSD which is equals to the 0.6. Output noise power n square bar equals to double integral of Rn of tau h of u h of v du dv n0 by 2 delta of u by u minus v h of u h of v du dv, which gives the relationship between the output noise power and the input autocorrelation function and the impulse response of the channel, whose value is equals to n0 by 2 u h of n h of t whole square dt, which is equals to 0.1 t cube. Output noise power equals to 0.1 t cube. Regarding part A, the output noise power is equals to 0.1 t cube, which is option A. Now we have to find out the output signal power. Output bit error rate equals to half complementary error function under root EB by N0 equals to 1 by 2 complementary error function under root SNR. SNR equals to EB by N0. Now SNR equals to output signal power by output noise power equals to S by 0.1 t cube. We know bit error rate equals to 0.16. From this, complementary error function equals to 1 by under root 2 equals to S by 0.1 t cube equals to 1 by 2. S equals to 0.05 T cube. Regarding part B, the options are option C is true. Here in part A, we have to find out the voltage gain of a given circuit. So in order to find out the voltage gain, we need to draw a small signal equivalent circuit of the following figure. Here plus or minus Vi, this is the gate terminal, RF feedback resistor is the drain terminal, RDS drain to source resistance, minus plus mu Vi equals to mu VGS. This is the source terminal, load resistance between drain and source, this is Z in, here is Z out. Now the voltage gain AV equals to VDS by Vi, which is equals to RL RDS 1 minus RF GM divided by RF RDS plus RL RDS plus RL RF. If we substitute the data given in the problem, we will get minus 10.35, which is option A is true. Regarding part B, in order to find the input impedance in the following circuit, we need to apply the KVL in the input loop, which is equals to Vi equals to II RF plus VDS. VDS equals to AV into Vi, which is a voltage gain which we calculated in the part A. Now if we substitute equation 2 in equation 1, we will get Z in as follows: RF by 1 minus AV. After substituting the data given, we are going to get 1320 kilo ohms, which is option D is true.